Today is the 4th of June 2024, and this will be our second video on the sector of the circle questions. Okay, I'm going to do this and I'm going to go into a bit of volume and we'll look at shapes in complex shapes in general. Okay, so bear with me, because normally if you explain the basic and you start dealing with the complex questions, then because you've done that, it helps the student understand more. Okay, now thank you everyone who have subscribed to our channel. Please invite others to subscribe, share, like, follow. It will be very, very much appreciated. And please, if the account is not yours, open your own account or ask permission. Okay, this is because of the future. You don't want somebody accusing you that you've misused the account when you know you haven't. Okay, or you don't want somebody being punished because you subscribe to something. Okay, if you do it, if it becomes your habit, then you realize that you wouldn't be using people's things anyhow. And even if you have to use it, then you ask for permission. So even though I would like you to subscribe, please do it right, get it right. Okay, in the comment section you normally see please follow my notes/script. Okay, I've always explained there are times I watch the video before I upload to make sure that I don't have any mistakes. Some of these examples I'm putting forward. Okay, because these are life-changing issues. You don't want to learn the wrong thing. So please follow the notes. Okay, follow the notes strictly. If I'm going to say 145 and it comes out as 45, please follow the notes. Beware of scammers, please. Please. Just beware of them, please. Okay. Now, recap. Yesterday we started looking at sector of circle questions, but I will take it to other shapes as well, because these are simple things that can come and you don't want it to come and then you have forgotten. Okay, area of the circle, circumference of the circle, primary students can answer that. Higher primary, they can do that. Okay, but sector of the circle, etc., immediately those things start coming in, then some students just give up. Please don't give up. I've done parts of the circle, so by now you should know what a segment is and you should know what a sector is. You should know the difference. Okay, so we've used this several times to solve different aspects of questions. Okay, now I'll recap today. Yesterday I told you that there was one circle theorem question where we were asked the reason and we had to mention verbatim the name of the circle theorem. So I thought I'll go back and use the starter every day, show you um, a circle theorem and give you the name, because I've told you, I've been frank with you, because I've used it a lot of times. I don't know the name off my head, but when I see the question, I'm able to know that, oh, if I use this theorem, it works for me. But unfortunately, I haven't made the effort to learn it with the names. I just use it to answer questions. You know what I mean? So now I'm going to use, even though I have a video on this, I'm going to use the status, and every day till I finish all of the circle theorem, I'll bring one circle theorem, I'll give you the name, and I'll show you. We've used it, we've done a lot of questions. The questions I have left, my next set of possible exam questions, I'll bring them. Okay, those are a bit challenging. Okay, so I'll give you a bit of break on that. So look at it. Angle AOB. That is, look at it. AOB. That angle here. We said O is the angle. Okay, the letter in the middle is the angle, and AOC. So AOC are subtended from the same arc. You remember yesterday we did arc length. So the arc BCA. So this arc here, okay, that is the arc here. AOB and AOC, they are subtended from the same arc. Okay, so if you can find an arc like this, okay, where you have AOB, okay, this converge at the center, and that is on the circumference. The angle at the center is twice the angle at the circumference if they are subtended from the same arc. So that is the arc here, from here all the way down here. Okay, so if this, I can be sure that this angle AOB and AOC, okay, I can find them on the same arc. Then the angle at the center here, okay, and the angle at the circumference, okay, so this angle will be twice. So if that is 40, then that will be 80. Okay, that is another circle theorem. So assuming you use this to solve a question, and they ask you that what circle theorem do you use, you say that because they are, these two angles are subtended from the same arc, this angle here is twice the angle at the center. The angle at the circumference, okay, will be, so if that is 40, that will be 80. Okay, I hope you get what I mean. Let me zoom in for you to look at the diagram. Okay, so that will be our second circle theorem. Now today, I'll use this for a recap, and then I'll continue, okay? And I'll do something with you that I got a question on, okay? So yesterday, we found the arc length, and then we found the area of the sector, okay? So the arc length, for instance, if you move from here round this sector to here, then that will be your arc length. All that is area. The arc length, you use the unit for length. The area, you use the unit for area. So to find the arc length, okay, because it's not a full circle, we are going to use theta over 360 times 2 pi r, because the arc length is part, a portion of the circumference. Okay, now here our angle is 160, okay, and it's not to scale. So 160 over 360 times 2 pi r is 3.1 meters. Okay, so our answer will be in centimeters. So because here we haven't been told to leave our answer as pi, okay, so when you do this on the calculator, you are going to get 8.7 meters to 1 decimal place. Okay, the arc length is length. Now again, that is a sector, okay, and we want to find the sector area. So the area of a circle is pi r squared. Okay, so that is the difference. So pi r squared, the angle divided by 360, because we want parts of the circle, not the full area. So again, 160 divided by 360 times pi r squared. Again, if you do this right on the calculator, you get 13.4 meters, okay, squared to 1 decimal place. Okay, I've always said mostly we work in centimeters, but be sure of the unit, because if it's in a centimeters, meters, and you write centimeters squared, then unfortunately, but normally most of the exam papers I've seen, they put the units, so you just have to insert the answers, most of them, which is very kind. Okay, now today's example, I'm going to just do minor sectors, because I got a question yesterday on my inbox asking me, how would you know if it's a minor or a major sector? Okay, now the full angle is the full angle in a circle is 360. Okay, so anything less than 180, half of the circle, is a minor sector. Okay, so even 179 will be minor. Anything greater than 180 is what? A major sector. Okay, so today I'm just going to bring examples of minor sector. Okay, so remember, anything less than 180 is minor, greater is major. Okay, so find the area of minor sector. So that's why I decided to do this. So maybe next time we'll look at some major sectors, and then look at that before we move on to do what we actually want to do. Okay, because I don't want somebody to be confused. It's a question, a genuine question, but at the end of the day, uh, just use the angle to solve it. Okay, so now these are, so the area of the sector is theta over 360 times 2 pi r. Okay, So this is what I was saying. Um, you think these questions are obvious, people should know, but at times it's a funny way uh, students think. I don't blame them, okay, because when I was at that age, um, I wouldn't see the way I'm seeing it now, okay, so um, and I've done it over and over again over the years. So I have learned some things. So at times, little issues like this can muddy a student up. So I thought I'll do a video on major sectors and I do a video on minor sectors. But now you should get what arc length means, okay? Whether it's on a major sector or whether it's on a minor sector. So this angle here is less than 180. So since you're finding this area, is the area of the minor sector. So assuming they gave you this diagram and they gave you that angle here and they asked you to find the angle of the minor sector, this is the angle you have to, so you subtract the angle you've been given from 360 and then you use that angle to find the angle, the area of the minor sector. I hope you understand me. So the area of the sector now would be 75 divided by 360. We are talking about area. So pi, our r is 9 centimeters all squared. Okay, 9 squared is 81 pi. 75 divided by 360. If you do this on the calculator, you are going to get 53.0 something. So 53.0 centimeters squared, remember, is the area. Okay, so that would be the answer here. Another example, this angle, okay, is less than 180 again. So theta over 360 times pi r squared, unless they ask you to leave your answer in pi, okay, simplify and leave your answer to one decimal place, okay, or what the question is asking you to do. So 88 divided by 360 times pi r squared, okay, and if you do that accurately, you should get 4.1 meters squared. Now let's look at another, and all these angles are not to scale, please. I haven't drawn them with the protractor, so please take note. Now this angle again, that is the area. So assuming they gave me this angle and then they asked me to find the area of the minor sector, I'm not going to find this area. I will subtract this angle from 360 and then use that angle to find the area, because this is the minor, this is the area I want. Okay, so the area of the sector here is 155 divided by 360 times pi. Our r is 3, okay, all squared. So if you do this nicely on the calculator again, you are going to get 12.2 centimeters. Some of these questions, too, at times, they don't give you the diagram. You need to sketch it to visualize. If you're a visual student, at times you need to visualize. For me, I use every kind of thing I can do to help me. So at times I have to sketch. Okay, that's why I will encourage you, like in probability, tree diagram, and all those things. Okay, some people can just look at the question, and so for some of us, even with the long time we've done it, we still need to look at it and visualize. Okay, because without that, so that's why you see a lot of drawing on my work, not because I like drawing, but it helps me answer the question accurately. So if you're that type of learner, just do what will help you to help you answer the question. So if you do that accurately with your angle at 155 degrees, you should get 12.2, okay, centimeters. Now, and also, if you're in an exam room and they haven't given you the diagram, you don't have to use a compass like I do here. It's because I'm presenting it to you, okay, and a protractor to make it look nice. You can just draw a freehand circle and try and put in your figures to help answer you, because if you've not been asked to do this and you do this nicely, it wouldn't give you any more marks. Okay, all you are doing is wasting a few minutes. But if they've asked you to draw it, or they've given you the diagram, then you draw, then you know that you are going to get a mark out of that. But if not, you can do a freehand drawing just to fit in the numbers and help you, because as I've always said, immediately you can fit in the numbers in the equation, everything else is calculation. Okay, but if you get this a part wrong and that part wrong, then in the end your answer will be wrong. Okay, so here again, 120 degrees, so 120 divided by 360 times pi, your r is 3.5 meters all squared. Again, having been asked to leave my answer in pi, so here again, when I simplify using the calculator, I have 12.8 meters squared to one decimal place. Okay, so again, please subscribe, share, invite others to subscribe as well, follow us, like us. Okay, help us send the message out. Okay, and please follow my notes slash scripts. Okay, as the other person did. How would I know what is a minor and a major sector? Okay, so tomorrow I will show you examples of major sectors. Okay, if the angle is less than 180, it's a minor sector. If it's greater than 180, it's a major sector. Okay, leave us nice comment, please. It will be appreciated. And your questions are also welcome. Okay, thank you very much for joining me in today's video, and I'll see you in the next.